Alright, welcome guys to another Calc with Colby. I know, 2 in 1 day. It's kind of crazy. We're going over 3.7b. I already did 29 and a bit of 35, so we'll start off with that. 29 was asking a rectangular package to be sent by a postal service can have a maximum combined length and girth perimeter at a cross section of 108 inches. Find the dimensions of the package of maximum volume that can be sent. Assume the cross section is square. So obviously the volume is going to be the base times length times height, and I guess length times width times height. But the width and the height are both x, they're both the same, and it's the length that's the only one that's different, so it's x squared times y, right? Then we set up another equation with the perimeter stuff that we got before, and this is where I was like a little bit confused. It says a package can have a maximum combined length and girth of 108 inches. So I was like kind of confused there, because, well, what is girth? Is that like, I guess it wouldn't be the area of everything aside from the length, like one side of the thing, but I don't know. I was stuck there for a bit. I'm pretty sure it was just like the perimeter of like a little section of it. So say you have the thing like this. Absolutely terrible drawing of rectangle incoming. Okay, it'd be like one little slice like here, like the perimeter of that little slice, so it'd go like through there, plus the full length of it, so all of this. I think probably, I mean, I don't really see how else that could be done, so that's what I went with. Then with that, you would solve for y, plug it back into here, right? Y would equal 108 minus 4x. Plug that back into here, v equals 108x squared minus 4x cubed. Take the derivative of that, set that equal to 0, equals 0. I mean, x could have been 0, but that's not physically possible, so don't think we're going to go with that. So we do 12x equals 216 minus 12x equals 0. Add that over, 12x equals 216 divided by 12 divided by 12. X equals 18. Plug that back up here. So y equals 108 minus 72. Y equals 36. So we'd have 18 by 18 by 36 inches. Something light. 35. The sum of the perimeters of an equilateral triangle and a square is 10. Find the dimensions of the triangle and the square that produce the minimum total area. So the perimeter of a square is 4x, because you have x, 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 and there's 4 of them, and you add them up. And then you have the perimeter of an equilateral triangle. So since all the sides are equal, you have y, y, y. Very simple. Now, that's equal to 10. And then for the area, because that's what we're trying to minimize, that's going to be x squared plus the area of an equilateral triangle, which we all know to be root 3 over 4 times side squared. So y squared. Obviously. So we're going to solve this for y minus 4x, 3y equals 10 minus 4x over 3, y equals 10 minus 4x over 3. Plug that into here, a equals x squared plus root 3 over 4 10 minus 4x over 3 squared. And we all want to take the derivative of this using our calculators. All right. So going to Calc, differentiate. We're going to do differentiate x squared plus root 3 over 4 times, and all of this is going to be in there, so minus 4x over 3 to the power of 2. Right, sorry. Equals 0. I didn't need that. Comma x and parentheses. Yeah. So me personally, I'm actually not going to solve that myself, so we're just going to... Oh, sorry. I forgot to set it equal to 0. Sorry, I forgot to solve for x, yeah. I don't like you. Mostly because I did that wrong. Solve should be here. Please work. All right. So x is going to equal... Okay, well, I guess I should write down what the derivative was. Okay. 2, 4, root 3 plus 9. So, why is this being so complicated? I don't like this. Thank you for breaking pencil. We appreciate you. We love you. Okay, minus 20 root 3 over 9. Equals 0. And then we're just going to say, yep, I can solve that. X equals 1.087, obviously. And now, plug that into here, get... Alright, so plugging that back into here, we're going to get a number. Okay, wait. Calc, you're going to help us out. 10 minus 4, 1.087 over 3. Y equals 1.884. Plug that into nowhere. I mean, I guess that was it. Yeah. How would I represent that? Like 10. Maybe I just write it as x and y. I don't know. But let's check to make sure that answer is correct. Okay. So we're actually gonna press the same button, except side of the square. I think we're actually just going to plug in what's in the back of the book here and see if that is, that's not what I wanted. All right, hold on 1 second while I do this. All right, so I plugged it in, and this gobbledygook gave me the same gobbledygook as the gobbledygook that I got up here, so x does equal what's in the book, I guess. I don't know about the triangle, though, so we'll see. 30 over 9 plus 4, that's not what I wanted, root 3. Remarkable, it's the same thing. All right. so now I just have to make that prettier. So side of square 1.087, side of triangle 1.884. All right, so that's that done. $37. Beam strength. Yeah, of course. A wooden beam has a rectangular cross-section of height h and width w. See figure. No. The strength S of the beam is directly proportional to the width and the square of the height. What are the dimensions of the strongest beam that can be cut from a round log of diameter 20 inches? So it gives me S equals KH squared W, except that W is far too big. Okay. Where K is proportionally constant. Rectangular, what? Oh, okay, that's a different figure. Okay. From a round log of a diameter of 20 inches, what? I'm so confused. Hold on. What are the dimensions of the strongest beam that can be cut from around? Well, I have two variables, technically. So I need to set, like, W in terms of H or H in terms of W. The diameter is 20 inches. Which gives me something, because, here, wait, let me draw up the picture here. So, it looks like this, right? That is 20, that's W, that's H. This tells me something, but I'm not sure what yet. Well, W is the same down there, H is the same there. Does the radius give me anything? No. Beam has a rectangular cross-section. What does diameter mean in terms of perimeter? What would the perimeter of that be? 20 plus W plus H for that triangle. But maybe I'm overcomplicating this. Can I find out the perimeter from this? I mean, obviously I can't find out W or H, but I don't know. Where do I go from here? So I'm trying to maximize strength. So eventually I'm going to take the derivative of this and set it equal to 0. That's simple enough. I think I'm gonna need 3 equations because I'm gonna need to define W, H, and K. But I can't do that because I don't know the strength, I don't know, and I don't know what H or W are. But I'm sure I can learn something from this diameter. I just have no clue what. I guess like W squared plus H squared equals 400 because of Pythagorean's theorem. Hold on. Solve. Well, I can solve for H squared, can't I? Yeah, minus W squared. W squared. So H squared equals 400 minus W squared. That plugs into there. Well, S equals K 400. Well, actually, I can just. Oh, no, I can't. 400 W minus W cubed. Which is something, but I don't know what K is. Does it matter what K is? Like, can I ignore K? I feel like I can't solve for K at all. So I don't necessarily... I guess I can go to the back of the book and then try to get an answer without K. If that works, then I'll just assume to get rid of K. Okay, 37. Okay. Well, it doesn't define K, so I'm just going to assume that K is completely worthless and should just be eradicated. All right. With K out of the way, this should be a lot simpler because we can take the derivative of this. S prime equals 400 minus 3W squared. Solve for W, set it equal to 0. 3W squared equals 400 over 3. It's like W equals 20 over root 3. Check the back of the book. If that doesn't work, that means I have to somehow solve for K, which I don't know how to do. You know what? It works. K doesn't exist. Okay. I mean, I guess it does say that it was proportionally constant, which means that it wouldn't change at all, so it wouldn't... Yeah, I just need to find the dimensions where it's the strongest, which means K wouldn't... If it's just the same all the time, it wouldn't matter. How it affected these dimensions wouldn't matter, I guess. Yeah, so W equals that, plug that into here. Get H equals, I'll have to do like some square root stuff, and that's like really annoying. I don't really want to do that. Bang. Square root of H squared equals 400 square root of 400 minus 400 over 3. I don't like how this pencil keeps breaking. Okay, so root 400 minus 400 over 3. 16.33. Or, well, I could do 20 times root 6 over 3, I guess. 20 root 6 over 3. Counterpoint, though, I want my numbers nice, so H equals 16.33 inches. and W equals 20 over root 3, 11.55 inches. All right, that's done. Now for 39. Minimum cost. An offshore oil well is 2 kilometers off the coast. The refinery is 4 kilometers down the coast. Laying pipe in the ocean is twice as expensive as laying it on land. What path should the pipe follow in order to minimize cost? I think we should make a free body diagram here. So we have oil well here, 2 km off the coast, right? OW for oil well. A refinery is 4 kilometers down, so we'll just call it R. 4 km. Laying pipe in the ocean is twice as expensive as laying it on land. What path should the pipe follow in order to minimize the cost? So you want to minimize the cost. I guess we can find whatever this is, but I don't know how relevant that would be. Well, we need to get from here to here in as little cost as possible. All of this is ocean. So all of that would be ocean, crossing ocean, crossing ocean. So that would be, I don't know. Yeah, I'm just going to figure this out because why not? It's root 20. It's root 20. Of course, it's 2 root 5. Thanks, Calc. 4.47. 4.47 km. I'm assuming this is going to be the answer, because it seems right. But, like, what if it's, like, bang, bang, you know? Okay. But, alright. So, what do I do here? We'll make X the amount of pipe laid in the ocean and Y the amount on the coast. So theoretically, we could do like X. What? An offshore oil well is 2 kilometers off the coast, 4 kilometers down the coast. So it looks like that. Laying pipe in the ocean, which is everything aside from this direct line, is twice as expensive as laying it on land. So X, okay, I actually have an idea now. So X is ocean pipe, Y equals land pipe. Okay, so Y equals 2x, the cost, I guess, equals 2x plus y. No, that's not true. No. This is not a true statement here. This is a true statement. But y equals 2x is a false statement. Also, we're going to move this down a bit. There we go. Okay. Now, I need some other equation for this then. I guess like x plus y equals 6, maybe? Sure, why not? Set that equal to y. So 6 minus x equals y. Plug it into there. 2x plus 6 minus x. So those cancel. It's just cost equals x plus 6, which, I mean, I guess this could be right, but taking the derivative of cost just equals 6, which means nothing. So I'm missing something, somewhere, somehow. Maybe it's like the distance formula, except I put a 2 outside of the thing. Hold on. Maybe it's like 2, wait, root 2, what would x2 be, and what would x1 be? No, that just doesn't work out. So, because I'm not trying to minimize distance, I'm trying to minimize cost. Let's see, what does the back of the book have to say about this? Probably something really interesting and helpful that's not just a number. Let's see. What? The pipe should go down the coast. Okay. Well, this is something. Um, 39's right there. No, I have no idea how we would get here. Like, what is this? Like, seriously, what is this? Why is this? The path of the... Okay, well, that's just describing. Did it tell me to? Oh, what path should the... Yeah, it did. Okay, well, how do I get here, though? 2 over 3. 2 over 3, I mean. Okay. So we have ocean pipe and land pipe. We have 4 over root 3 ocean pipe and 4 minus 2 over root 3 land pipe. But how do we get that, and that? That doesn't... This math does not add up. You know, it's really, really interesting how I have no idea how to do this. In fact, I don't even know where I would start. I mean, I guess I was right with my guess. It could be something like this going down, but I didn't have numbers behind that. Okay, I mean, but this makes no sense. How would we even get that? What the heck? I'm gonna pause this until I figure something out, or I give up. I'll be back. Alright, yeah, I'm gonna be completely honest. I have no idea how to do this. This is rough. Yeah, no, I have no clue. I mean, I'm just gonna, erase all of my work here, and then, I mean, I don't even know where you would start. I guess, like, maybe something with the distance formula? I don't know. This seems like a Mrs. Jekyll question, so I think this is going to be it for Calc with Colby. Good luck on the quiz tomorrow, guys. Have a great time. Bye-bye.